Hi everyone, this is Prabhat, and today we are going through single linked list, and that too. The concept is we just need to create a linked list, right? And we need to get elements into it, basically get the input elements and store it in a linked list, and then we need to traverse through it and print every single element's data. So basically, what we are going to line by line, first of all, understand, and then we are going to try to understand the overall concept of linked list and how it's functioning, right? So first of all, we've got include keyword and we include stdio, and then we again use include keyword, and this time around we use stdlib.h. Next up, we basically create our main function, and within the main function, we are creating a struct. We are creating a user-defined data type, which is struct node, right? So this is just a user-defined data type. This is something. This is a data type that we are creating, and the name of the data type is node, and struct keyword is used alongside all of the user-defined data type, right? So this is going to construct a box-like structure with a data field and a pointer field, a field in which pointer to the next node is going to be entered. Now, for now, just bear with me. This is something that I'm going to explain in a while in the same video. But just imagine that there is going to be a box in which two items can be kept. One item will be the data, and second item will be a pointer which will be pointing to the next element that is going to be created. And if there is just one element in the next I mean, just think that there is a linked list which has just single element, single data field. Then the pointer to the next node will be pointing at null. So basically, it's going to have no address and it's not going to be pointing anywhere, because that's a good practice, right? Remember, if you're creating some sort of node and then you don't have any elements after that, or yeah, so basically you don't have any elements after that, especially in a linked list. You want it to be pointing at null and not anywhere else, because that's going to cause some issues later down the line. Then we are creating a choice variable. This is so that we can keep getting user feedback as to if they want to continuously keep adding elements using this while loop. See, what is the purpose of while loop? While loop serves the purpose of checking if a condition is true. If a condition is true, then it's going to execute something. So as long as user does not type 0 and just presses anything else, we are continuously going to keep getting input and adding new nodes to the linked list. So that is what the choice function is for. And then we've got struct node pointer head, right? Asterisk symbol denotes that we are creating a pointer variable. This is a pointer variable. Pointer variable points at basically a specific address. It holds a specific address, right? So for now, just imagine that we are creating four pointers: head, tail, new node, and temp, right? Head is for pointing always to the head of the linked list. The first element in the linked list is always going to be pointed by head pointer variable. Tail is for pointing to the last element in the linked list. And let's say that there is just one element in the linked list, then tail will be pointing at the same address at which head is pointing. New node is something that is going to store the address of every single new node that we create. So basically, we have our node, struct node data type, right? So whenever we allocate memory to this, then we are returned address that specific block. So that address will be stored in new node, so that we can use new node, and then we can new node and then we can enter data into it. So that is pretty much it. And this is for like we are creating basically a data type which stores data and address to the next node, and this will contain null if 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 no data is present after that. and then this is choice variable. These four are pointer variables. Temp is used to traverse through the array. I'm going to explain what traversing is. This is a while loop. So basically, every single time choice is going to be true, uh, we are going to create a new node. Now, why do you think that I have not initialized choice with 1? Because remember, if I don't initialize something with a value, then garbage value is stored, right? And garbage value is normally not 0. So if the garbage value is something like this, 1, 2, 3, 4, 5, 6, something like this, if this is the garbage value, this is not equal to 0. And if it is not equal to 0, that means it is not false, it is still true. So while loop is going to execute regardless of anything one time at the very least. So that's intelligent, is it not? We can make sure that everything is correct by initializing it with 1, but I'm not going to do that. And then at the very least, as I said, one time while loop will run, and we will this code right over here. We are saying we are calling the malloc function, and we are telling that whatever is the size of struct node. So this can be of 4 bytes, and this can be of like 2 to 3 bytes, 4 bytes, whatever is the total amount of bytes that it stores. Let's say that it's 8 bytes. So 8 bytes of space will be created, an address to that specific location in our memory block. That address will be stored in new node. Now what we can do is we can print this message. Where did it? We can print this message enter data, right? And then user enters the data, and that data is stored in the data field of the new node, right? So the node that was created is in its data field. We sort of store that, and then we store null in the next field. So we don't necessarily know if the user actually wants to create a new node, so we have stored null in it, null in the next field. We are assuming that they are not going to create any node after that. And then if head is equal to null, well, I'm going to explain it better. But this is basically the code where, wait a second, let me explain it better using this image. So initially you can see that when struct node is declared, right? Nothing, there is no element in the linked list, and head is pointing to null, tail is pointing to null, right? Temp is pointing to null, new node is also pointing to null. So whenever a new node is created, new node is now pointing to the address of the newly created node, right? New node is going to be pointing to the newly created node. I'm just having hard time explaining all of this. I'm just going to explain how things work. So yeah, so new node is created, and new node has data in it and null in the next node. And then we are going to check if head is equal to null. If head is equal to null, that means there are no elements in the list, right? So if there are no elements in the list, then we are going to store the new node's address in head node. I mean head's address and temp address, because head and temp are pointer variables. They store address, right? So they are going to store address of the newly created node, right? Because if head is null, that means there are no elements. That means the element that is currently being added by the user, the element that is currently being added by the user is the first node. And if it's the first node, then head must point to it. That is it. Now let's say that let us say that user is entering the second node. Then again, new node will be created, its address will be stored in new node, and then we are going to store data in the new node field, new node's data field, and then its next field will store null in it. Now what we want to do is we want to I mean, we have our temp variable, right? Temp basically refers so temp is something that should be pointing to the first node, and what we want to do is we want to store in the first nodes, because first node has been created and its next field is containing null in it. Then the first nodes. next field should be pointing to the newly created node so that they can be linked together. So initially when we create first node, we've got data in it. So let's say user enters 1, then in the data field 1 will be entered and this will have null in it. When we create a second element, we enter the data which is 2, and remember this must be connected to the second node. So how will it be connected? This you can see that the address of second node is 100 and address of the address stored in the next field of the first node should be 100 as well. That way we can use this address to go over here, then we can use this address to go over here, right? We can access, we have the address, so we should be able to access this block. If we have the address of 59, then we should be able to go to this block. That is the whole idea. And then we have the address of 99, then we should be able to get to this block. And then finally null is stored, right? So in the last node null will always be stored because this points to nowhere. If we don't store null in it, and if some garbage value is put in here, and that garbage value is the address of specific node, then it's going to like cause un basically a behavior that we don't want, right? So we don't want that. We need to make sure that we explicitly make sure that this is null, and we have already coded in a format that null will always be stored unless next node is actually added. So I hope that you get the point why we are storing the address. We are storing the address that so that we can access the next node, right? Wait a second. Yeah, there you go. So second node is created, and in the first node, in the previous node, we store the new node's address so that new node is accessible from the previous node. And then we do temp is equal to new node. So we update the temp so that temp is now currently pointing to the new node. And again, if user wants to add the third element, we can use temp of next, which is the second node's next field, to store the address of the third node, right? So this is why this code is there. And then we ask the user whether they want to continue adding nodes. So if they enter 0, the program is going to break. It's going to end. The while loop is going to end execution, and we are going to take it as user does not want to enter any node after that. And if they enter anything that is not 0, which is also uh, hopefully an integer variable, then integer data, then the program is going to continue executing. Then traversing is the process in which we go through the entire linked list, and in this the reason we are traversing this time around is to print all of the data. So remember, we get all of the input, now we want to print the linked list. Right. So initially we point the temp to head because remember temp was pointing downwards as the new nodes were being created. Temp was continuously pointing down and down and down. It was going down the list. Now we want to point it to head so that we can use the temp variable and traverse through the array, through the linked list. The habit is of calling arrays, so I just cannot help but say array. So temp will be pointing to the first node now. Now we will while loop is something which executes as long as the condition is not false. So temp is not equal to null, right? Because head has some value in it, some address in it. So temp is not null right now. Temp has some sort of address. So it's going to print the data of temp. So first node, which is the head node, remember we put the address of head node in the temp. So currently temp is pointing to the first node in the linked list. Then what is going to happen is that we are going to use the data to access. Right. Remember, this is important because this allows us to access the data field and the next field. So temp of data, or rather the data field of the temp current address, the first node, we are going to print, and we are going to break the line and go to the next line. And then what we are going to do is we are going to assign temp to the next. So remember, again to the two over here. So initially temp is pointing over here, then it's going to access data field and it's going to print 1. then it's going to change the line. It's going to go to the second line, and then it's going to access. It's going to have temp is going to now have updated value of temp will be temp of next, right? What is temp of next? Temp of next is 100, so temp will now be pointing at 100. So while loop is going to again loop over, and this time around temp of data will be 2, right? Temp of data will be 2, and then temp is equal to temp of next, right? So temp of next is 55. Now temp is equal to 55, right? So now the temp is equal to 55, we are going to again loop over, and then come over here and print temp of data, which is 3, and then again the temp will be temp of next, which is 59. So we are going to point over here, then again we are going to print temp of data, which is 4, and then we are going to again go to the next field. So temp is equal to temp of next, which is 99. So we are pointing now over here. Again we are going to do temp of data is equal to 5, temp of data, and this is going to print 5, and then again temp is equal to temp of next, which is null. Now temp has null in it, and we are checking if temp is not equal to null. So temp is equal to null, and we are checking for temp is not equal to null, so this is going to result to false, and if it is false, then while loop is going to break. Then we again, this is just code for again traversing again, but this time around we are traversing to free the address that is allocated, or the blocks of memory that is allocated to every single node. Because remember, uh, the a malloc function, whenever we are using this function, malloc function, it's going to create some space in the heap, and if you don't free it I mean explicitly by calling the free function, you if you don't free every single block of memory, then it's going to remain, the data is going to remain in the heap memory, and it's going to cause memory leaks and all that. So that's definitely a bad thing. So we are going to traverse over it, and we are going to free node, free every single node. So I'm not really going to go into and explain this. I perhaps will make a new video, different video about it, or you can actually try to understand this by your own. If you understand it, that's fine. Uh, if you don't, then I'm going to definitely make a new video about it, and explain it to you. So let's just run list. First of all, we are going to have to go to traverse traversal, right? Traversal. Wait a second. Mm, Again, I made mistake in the spelling. Traverse, Traverser. This is the spelling. And then we are going to do a list, because list is the executable file name. And then data one. Yes, we continue adding two. Yes, we continue adding three. Now we don't want to add anything. So first you see what happens. First we traverse through the linked list, print 1, 2, and 3, and then we free the memory of data 1, data 2, data 3. So this is all I wanted to show you. Thank you for watching.